For this section of notes, we're going to talk about types of matter. In this graphic organizer, you can see that there's two main categories of matter. It breaks into pure substances and mixtures here. Pure substances are either elements or they're compounds. I wrote a couple different elements here, hydrogen, oxygen, and carbon. I drew carbon here. You can see every atom is the same. I also drew some hydrogen gas here, and again you can see every atom is exactly the same. Compound would be CO2, H2O, and you can see here that there's two atoms bonded together, but they're each different from each other. Mixtures then are two different types, homogeneous, which are also called solutions. These are the same throughout, and then there's a heterogeneous mixture, which is different throughout. So as we define matter, matter is anything that has mass and takes up space. Another way to think about that is usually you can touch matter, and it's always made up of atoms. Air is something that's a little questionable. It doesn't seem like you can touch it, but it is there, and if you fill a balloon with air and put it onto a balance, it does have mass. So that's something that can kind of be a little bit tricky, but air is considered matter too. So comparing pure substances and mixtures, with a pure substance, every piece is exactly the same, so I tried to draw that here with carbon molecule, or carbon atoms, excuse me, all the same. Hydrogen molecules here, again, every piece is the same. And then with water molecules, those are both the same also. When you have a mixture, there's all different types of particles all mixed together. Not any of them are necessarily the same. Then elements versus compounds. Elements, every atom is the same type. So you can see here if these are carbon, every atom is black, the same size, same shape. Over here, if we have hydrogen, each hydrogen atom has every hydrogen molecule has two atoms here hooked together, but they are all the same. A compound, more than one type of atom chemically bonded, so again they have to be showed that they're connected together, and every molecule though is the same. So each one of these things is a molecule. They are each the same, even though the atoms that make up that molecule are not the same. So more than one type of atom bonded together, each molecule then is the same. So things that are important about atoms, they're the smallest part of matter that we can have, so they can't be separated. They have electrons, protons, and neutrons in them. Elements are pure substances. Every atom is the same, and you can see that here in this picture, every single atom exactly the same, and we find those on the periodic table. Compounds, again, they're pure substances. Every molecule is the same, so if you look, this is the same as this, which is the same as this, but each molecule is made up of more than one type of atom, and they are bonded together. These we can only separate by chemical reactions, so if I wanted to take this hydrogen off this oxygen, I would have to have a reaction so that bond could be broken. Mixtures then, homogeneous, again, those are called solutions, same throughout. Heterogeneous mixtures are different throughout, so sometimes they're going to have chunks, bubbles, floaties, layers, different things that aren't necessarily the same all the way through. So when we define mixtures, more than one type of matter, they can be separated, usually fairly simply. They are not just one pure substance, they're more than one type of pure substance. So a couple examples would be if you have an element and a compound mixed together, or several elements and several compounds. You can have a whole bunch of elements mixed together or a whole bunch of compounds mixed together. Those are all different ways that we can combine pure substances. And then the last little thing we have here are the different phases that we can use to make mixtures. We can have two solids together, solid and a gas, a solid and a liquid, more than one liquid, a gas and a liquid, and two gases. All the examples are here. There's many more, but these are just the different ways that mixtures can be put together.